Hey, kiddos! Here we are making the video. And you might be saying, Mr. Lilly, where are you? We can't see your face. Normally you're in the bottom corner of the videos. It's definitely not because I had an allergic reaction and one of my eyeballs is almost swollen shut. That's definitely not why. Not at all. 27 votes on this question, so that's cool. When you have an object, like a ball or a block, as it falls, can you do the collision work for that object when it hits the ground? Yeah, you totally could. Nothing would really stop you from doing that with the ground. The issue with doing, if it were to be hitting the ground in terms of an impulse momentum deal, is now we're dealing with gravity, right? So now gravity is playing a role, and if as it was hitting the ground, gravity would be helping that, right? And as it's leaving the ground, gravity would be working against that. So that would make it a bit more complicated, maybe a bit too complicated. Wink, wink. Now, see, normally I would have just winked, but you can't see that. So, wink, wink is what I'll say out loud. Fantastic. In the illegal AP classroom. Okay, it's not an illegal. I don't know who wrote this. Thank you. It's not an illegal question. It is very legal for me to have it. It's illegal for you to steal it. Like, there's like a big difference between illegal and like, oh God. Legal. There's nothing wrong with the fact that I have that question. It is 100% legal. And if anyone's listening to me, it's legal to have the question. There's nothing wrong with it. It's okay that I have the question. Thank you so much. Why can we use conservation of energy if the collision is perfectly inelastic since the carts stick? So, in that question, we were using energy before the collision, so it didn't matter. Right? If I have an object on a ramp and it slides down a ramp, it doesn't matter what it's going to happen to it later. It didn't matter what happened before. What matters is that, during the ramp, I'm allowed to use it. The collision itself is perfectly inelastic. And for the collision, we would not be able to use energy. But for the beginning part, we totally would. Can you go over the process? What is with everyone calling it the illegal problem? Who are you people? It's legal. There's nothing wrong that I have my own. It's like that you guys are saying, oh, that's an illegal piece of broccoli that you bought from the store. No, guys, it's fine. Just because I didn't grow the broccoli, it's totally okay. Now I could kind of go for some broccoli. Not necessarily like steamed broccoli, but like, yeah, maybe very lightly steamed, and then like throw some like fancy seasonings on top of it, maybe a little Parmesan Reggiano. Great. Well, I can't go over the process for the illegal problem, but what I can go over is any problem. Let's switch to our whiteboard. If I have an object, it doesn't matter what the scenario is with that object. What I need to do, first and foremost, the first thing, if I'm going to try to do some sort of collision, and look, here's my software crashing. And there's a random alarm going on. Guys, do you ever have those days where it's just a little rough? What is he having, a dog day? The dog days are over. I think there's a song. Florence and the Machine, maybe? Alright, let's get back to this. For any collision that I'm going to do, doesn't matter what type of collision or what it is, the primary thing, right, first is I need to know how fast are these objects going before they're going to collide. If you don't know how fast they're going to go, how are you going to do anything, right? I'm going to want to probably also know, be super helpful, to know the type of collision. You are absolutely correct, because will they bounce? Will they stick? Will one move? Will the other move? Sometimes we don't necessarily know the type, but they do tell us something about. So like maybe let's see, I had like two carts, right? And this one's not moving, and this one is moving, and then maybe like after the collision, we'll call this A and B. Cart A, maybe I told you that like cart A is stopped, and then cart B is moving. So not necessarily the type, but you want to know something about what happens. It can't just be like two things hit and you don't know anything. You gotta sort of know something about them. And then from there, probably conservation of momentum would be the easy way to do this. That's the way we're going about that little conservation of momentum. Yeah, and so if I had just any problem ever that's not illegal, because I'm a teacher, I'm allowed to have things. Jeez. With two carts that we're gonna hit, right? And then let's say they were going to stick, and the question was like, what's up next, right? This is classic P before, P after. Well, in the beginning, how many things do I have moving? I have 2 things moving. And then in the end, I have a singular thing, which you could call it 1, 2, or you could call it P cis. If only there was a review video on a certain YouTube channel where you could go look through the full process of that. Boom. Next. When we're calculating impulse from a graph, is there a particular way that you want us to indicate that we're calculating it from area under the curve? Yes, I would like you to write area under the curve somewhere. It would be super helpful. Or clearly show that you're doing area under the curve, because sometimes you guys just randomly multiply numbers and then like, oh, you should know. You have to be very clear with that. How does N3L and conservation of energy momentum work with a wall? And then, well, this one got sassy here in the comments, huh? So, this original comment, I don't know what you mean. There is a homework that is identical to this, so feel free to look back at that homework. But conservation of energy and momentum work for systems, not singular objects. So to talk about a ball conserving momentum on its own is not an appropriate conversation, because singular objects gain and lose momentum. Singular objects gain and lose energy as well, right? So to talk about just a ball hitting something, right? Now, the problem is, and we're not going to get into this, I'm not going to humor this conversation any further, because it's much more complicated with the wall. Like, it's really, really complicated, and you don't want the answer to this, is the simple answer here, right? It is, there's a wall that's connected to a ground, which is connected to a floor, which is connected to a foundation, which is connected to the earth, which is connected to the bedrock, right? There's so much other things going on that we don't account for. So the important part of this, though, is singular objects, singular thing, do not conserve momentum or energy for that matter. Systems of multiple objects, that's when we can conserve stuff. But go back to the homework with a ball, not the wall. Can you explain when to negate the impulse and if you do that with other things like momentum? So with this question, it makes it feel like I feel like this is like when do I just magically choose to negate things? You don't. That's the simple answer. In that homework that I believe you're referencing, right? We didn't make a choice to negate things. It's because of their direction. It's not that I'm looking at a problem and I'm saying, oh, this is negative because I want it to be. No. Things were negative because of their direction. And once you choose a direction to be positive, things that aren't that way are negative. That's not a choice I'm making. I'm not saying I want to pick this way to be positive, or I want to just magically negate this, right? Things are negative if they are negative. If we go back to our drawings, right? If we have like the scenario where we talked about with the one homework, where I have these 2 objects, right? The block would push on the right. The block would push the ball this way, right? And then the ball would push the block this way. So the impulse that's this way, right? There'd be a certain amount of impulse, and there'd that other impulse is this way, and these 2 have to be the same magnitude because impulse is force and it's related to third law, but these aren't the same directions. So it's not that I'm making a choice of negation, it's I'm choosing a direction to be positive, which has consequences, and one of those consequences ends up being one of these has to be negative because of directional choices. But it's not I'm randomly negating stuff. So it's not that I'm just choosing to negate stuff. No, I'm choosing a direction to be positive. So be very, very careful with that. I cannot run from momentum, I believe. When negate, oh jeez, it's like, did you guys just read each other's things and put one right below? When negating impulse, should we indicate why we negated in a sentence? So Malia, thanks for putting your name on this one. It's good. We'll talk directly to you, Malia. You should not indicate that you are randomly negating something, because if you are randomly negating something, it is not going to be a good time for you. However, if something was negative because of its direction, you should have somewhere in the problem indicated the direction that was positive. Therefore, that other direction would in fact be negative. So it's not that you would have to negate or you'd have to like write a sentence as to why you're negating. You would instead somewhere in the problem state what direction is positive, and that would easily account for that. Great. Hope that helps, Malia. We want to justify if something is elastic or inelastic. Is that where we can use energy? Georgia, yes. So if the question is it elastic or inelastic, you can easily use energy, because if energy is conserved, it has to be elastic, and if it's not, then it can't. Could I please explain conservation of momentum and conservation of energy in relation to elastic? So momentum is always conserved, period. Conservation of energy is only conserved for elastic collisions. So for the most part, since we are in the unit right now of momentum, you should use conservation of momentum. Could you maybe might be able to use conservation of energy on a problem or two? Maybe. Would it be likely? No. It'd be more likely that you would use momentum on the momentum assessment. In the future, though, the big thing is if it's elastic, energy, elastic, you'd be allowed to use energy. 602, there is no change in vertical momentum, although the ball travels at an angle and is vertically higher. All right, so Rowan, momentum is not displacement. So although, yes, it does change vertical displacement or vertical position, that does not correlate to momentum. Momentum is all about speed, right? How fast it's going, and also the direction that correlates there. The wall can only in that problem push horizontally, right? And that specifically for that problem, the wall was pushing to the left. So since the wall pushes to the left, the only changes that can be made are to the left, which would be in that problem horizontal. So we can't have any vertical changes. Ooh, we're down to the 0 votes. See if there's any 0 voters down here that are good ones. Liv, I think I answered this earlier with George's question. So if they're, yeah, right, you got that. Y in 601. All right, so this has no units anywhere on this, so I'm tempted just to delete it like it never existed. So please put units on things if you'd like them to be answered. It'd be good. But what I will tell you is milliseconds is not seconds. Would you be able to give an example of when to use P before P after? Jordan, if it's collisions and you know all the things, the easiest way. And what does this person say? Yeah. Jordan, what I would point you to, there might be a review video up on a certain website that has a great example of some P before, P after stuff. Fantastic. In 604, we are able to find the collision as inelastic. I understand that we compared final. Right. So, but Jordan, so there has to be some indication of, there has to be some indication of whether or not it's an elastic or inelastic collision, unless I don't want to tell you, and I want to ask you that question. Like, I'm allowed to ask you questions without telling you the answer, which is, I feel like, what you're asking. So we might have a question where I'm going to ask what's going on instead of just telling you what's going on. But correct, in most problems, most, not all, but most, you will be told what the collision is. Oh, cool! Look at that. We're at the end of the video. Wow, we answered all the questions. Good job. More people voted for this one. That's good. All right, we did some. Okay. All right, we did some good things here. I hope that you can get some good practice, good review going. Final thoughts. See, it's weird because I guess you can't see that I'm here, so you don't really know what I'm doing, what I'm saying. But I am still here. Are you still listening to me at 14 minutes? Man, yikes! And again, imagine if I snuck a super secret bonus here. Bonus. Any of you guys watched the Marble League Winter Final? Ice hockey? It's not hockey, but I did enjoy it. For sure not hockey, but still pretty fun and enjoyable. Cool. Assessment. Remember, we really have two different style problems, JFAT, Fat Mav, Delta P, all those, and then the other distinct style, which is different, is P before, P after. I think looking at the homeworks, you do have some good examples of those. Also, if there's another review video that went through all the concepts, that would be probably a pretty important video to check out as well. Yeah. Do I have anything else? Do I have anything else to say right now? I don't know. I don't think so. I think that's all that's in the brain. Right now we're heading 15 minutes. See, now I wonder how long I could ramble before no one's watching anymore, no one's paying attention, except like 8 of you. That like probably, and it's probably the 8 that would normally be in academy period, you know, like the normal crew. But what if I was saying like something super secret? Like something secret about the assessment, like problem number 7 will be dun, 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 dun. There won't be 7 problems. Probably. There might be. Nah, probably not. Maybe. But maybe. Probably not. Maybe. Nah. Maybe. Nah. How long can this go on for? I just sort of randomly talk about stuff. Okay. Goodbye, everybody. But see, what if I came back with just one more super secret thing, you know? And then I was just like, ha, bye. But then like I pop back with another super secret special. Like, don't forget, on the last question, the answer is gonna be about my favorite type of ice cream. Imagine if I just kept doing like over and over, and like one of these was real in terms of being like a super secret special, you know, and like you had to like really, really watch the video, really pay attention. Yeah. I hope you guys are staying safe in the snow. Okay, bye. For real this time. Bye. you said you thought I said goodbye for real. It wasn't for real, it was for fake real. All right, just now this time. Now it's for real this time. This time it's for real though. Now it's for real. This time it's for real. Goodbye.